Okay, guys, good morning again. I'm recording this video for the other more exercises. So let's go to the intermediate level so you can work into that part. I wanted to pay attention. I want to get started for you to share this part so you can see it. Yes, it is in there. Well, as always, like I said, for this exercise, you're supposed to balance a reaction. If you remember how to do it, you can use redox method. Like I could make another video for that part, but specifically this is for calculation. So remember there was 13 there. You need 3 phosphorus there, and in here 6, in total 12. Obviously you need 13 metals, that's why you have there. And in the case of sulfur, you will need 9 because 3 times 3 would be 9 sulfurs, that would make it. Okay, so for doing this specific calculation in groups, it says the part A, how many grams of potassium, right? How many grams of potassium there? Potassium chloride form each time 0.001 moles of P4S3. What we're going to do there in the first place is going to, as always, how many grams potassium chloride is what you're looking for, right? Starting with what? With 0.001 moles of P4S3. So what's the meaning for that? If you want to draw the arrow, you're going to move from this one, from the data you have to what you're looking for. In your reaction, what's the meaning for that? Where's the P4S3? It is in here. You're going to move to potassium chloride, meaning that the arrow is going to go from the what you have in the data to what you're looking for. That is, I put the arrow into the reaction so you can create or construct the conversion factor, which is given by the reaction, okay? And then let's get started to calculate. Since it says that you're supposed just to write that, I wanted to write a 0.001, it says mole, right, of P4S3. P4S3. Got it? And then you're going to copy the calculation of the ratio from your chemical reaction. My chemical reaction is saying that I have 3 moles, right? 3 moles of P4S3, right? That's what it says. And that is related to what we're looking for. In this case, is grams of potassium chloride. So let's write moles first. How many moles of potassium chloride? Oh, it says 13. So you put 13 moles of potassium chloride. Also, we're going to do the important, if something important for you to remember, after writing that, you read the reaction states grams. So then in the lower case, you're going to put 1 mole of KCl, and in the upper part, you must transform that to grams from previous reaction. You know that's the mass from the periodic table, 74.55 grams from KCl. Okay. Once you have that, you're going to write that equals and sorry, I have the keyboard in Spanish. Okay, and that equals. And then, well, what I just did is just put in the conversion factors there. I'm going to enclose them so you can see them in a better way, right? This spot and this spot. And at the end, what you're going to have is an answer. What's going to be, you insert those values into the calculator, the upper part times the upper part times the upper part divided, open parentheses into the calculator, divided to open parentheses, 3, sometimes in this case it's over only 3, but there could be longer calculations here, which you're about to see. It is 0.323 grams of KCl, okay? That would be the answer for that one. Let's read for the second one. It says, if 4.4 grams, right, of KClO3, so underline that, that's my data in this moment. How many moles of SO? Moles of SO. Okay, I have that. So I'm going to write, says that move from this data to this one. From that data to this one. I'm going to use another color for writing this arrow in the upper part. So let's write, let's use this yellow color because I like it. Okay, it says from KClO3, from KClO3 to where? To moles of SO. So we're moving here, there, to moles of SO. If you understand that, let's continue. Okay, I am transforming grams of KClO3 to moles of SO. So what you have to do is just, again, copy the exercise, copy the data for 4.40, right? It says grams of KClO3. And again, now you must transform, right, the grams to moles because the reaction is talking about the coefficients, so talking about grams, so let's work in grams. I know that 1 mole of KClO3 has the mass of 122.55 grams of KClO3. How do I know that? Because I have the periodic table. You just add the masses. We have practiced that before, so pretty easy to know. What else? You need to know that also my reaction says that 13 moles, I put 13 moles in the lower case so I can cancel with the ones from the upper part, KClO3, right? And in the upper part, right, I'm going to put that in here, exactly. And in the upper part, well, I'm sorry, it's in the lower case, yes. And in the upper part, exactly. In the upper part, you've got exactly, it says that 13 moles of KCl3 are related with 9 moles of SO, right? And that would make it because the question is only asking about moles, not grams. If it was grams, you would have to do an extra step, right? And then let's get back to the color we were using. You have this, conversion factors, again and again. And then you are going to put equals and it's going to be basically done. If you insert those values, you're going to multiply 4.40 times 9 divided to open parentheses to 100.22.25 times 13 and the close parentheses into your calculator. If you don't do that, you will get a wrong answer. So if you do so, this is going to be 0.025 moles of SO. And that would make it in terms for the answer and stuff. So important to remember, just for you to see, we have canceled in the case for this moles of P4S3, moles of KCl, and at the end you just remember what you were looking for, which was grams of potassium chloride in the uppercase, right? Also, for example, in here, grams of KCl3 with grams of KCl3 go. Moles of KCl3 with moles of KCl3, and at the end I just remained with moles of SO, which is what I was looking for. That is important for you to remember, guys. And also, something in here in this reaction in exercise A, for me it was important this part, right? What was that one? That came, this conversion factor came from the chemical reaction, right? Chemical reaction, right? Chemical reaction. And the other conversion factor, as you can see, that one came from, right? Came from where? Came from where specifically? From what? The periodic table, exactly. But look at this, in the other exercise, it was a little bit different because I started with grams. So first of all, this conversion factor, that comes from the periodic table because I started with grams. And the other conversion factor, right, came from where, right? Exactly, if you're thinking about that, I feel like Dora the Explorer right now. You would have from the chemical reaction. Okay, my dears, so that was it. I hope you are taking notes about that and stuff. I'm going to finish the recording right now. So I'm going to stop the sharing and I'm going to stop